When you're learning about equations of a straight line, one of the equations you'll see very often is y equals mx plus c. But what does that even mean? So in this video we're going to just look at the m, and strangely the m is the gradient. So the gradient is how steep the line is. So if we take this line here, what we're looking for are two areas in the graph where that line exactly hits a point. So you're looking for a point on the corner of one of those squares. Hitting this point here isn't any good. You would need to hit that point there. So for this one, we're finding 2, and I'm going to use this point here and this point here. We draw a triangle to join the points up. Now the line along the bottom, you can call that the run. That's how far the line runs across. And the line going up, you can call that the rise. That's how far the line rises up. To calculate what this means for the gradient of the line, we say rise divided by run. You'll probably more commonly see it written like this: rise over run. The rise is 1, so that goes at the top, and the run is 2, so we're dividing 1 by 2. You can probably see that that's a half. So the gradient of this line, m, equals a half. What this means is, if we start with that first point, as it's run across a complete square, you can see it's only gone up half a square. If we run it another whole square, you'll see it's gone up another half a square. So it takes 2 runs, 2 squares, for that line to reach the next square, the next point going up. From that point that we've got to, if we do another triangle there, you can see that the run to get to the point where it's going to reach that line is 1 whole square, but the rise is just half a square, and that carries on there. If we do another run of 1 square, 1 run across, and a rise up is another half. So the gradient of the green line is a half. Here's another one. This line is much steeper. If you imagine skiing down that line, that would be a very steep fall. Again, we're going to look for 2 points where it exactly hits the points on the graph. So I'm going to use that point there and that point there. We'll do my triangle, my run and my rise. The run goes across 1 square and the rise goes up 4 squares. Remember, it's rise divided by run, so that's 4 divided by 1, which is 4. So m here is 4. The gradient is 4. If we go to the next area where that line hits a point exactly on the corner of a square, you'll see that that's a run of 1 and a rise of 4. When you're calculating the gradient, it doesn't matter which 2 points you start with, as long as you have 2 points that exactly hit the corners of the squares on the graph. So for example, for this one, you might have started using this point down here and that point at the top, because they were clearer to see straight away, perhaps, than that one in the middle that we used before. And in this instance, you'll see that the run would be 2 and the rise would be 8. You'll still get the same answer, because rise divided by run, 8 divided by 2, you'll see that the m still equals 4. The gradient of this line is 4, and if you look, the next point that you get to on that line that hits the points exactly in the corner of the square has a gradient of 4. So it doesn't matter which 2 points you start with, you'll still get the correct gradient.